What's up, YouTube? In today's video, I'm going to be discussing and introducing to you the adapter pattern. This is an interesting pattern. I mean, all patterns are interesting. What happens when people encounter this pattern, a lot of confusion arises. I think that happens with a lot of the patterns where you can't distinguish between the one pattern and the other pattern. And we'll talk about some of these patterns, the patterns that people consider to be similar to or get confused with the adapter pattern. But really, this is nothing to do with the adapter pattern itself. I'm probably just taking the opportunity to talk about some of the confusion that people might have in this video, because this is a simple enough pattern, and yet it is a bit confusing. So, and we'll go into the details of that during the course of this video. I'll be showing you some real world implementations for the adapter pattern. And the source code for that will be available on my GitHub. So if you want to examine that code in more detail, you can look at it from my GitHub repo. In the video, I'll just discuss the reasoning, the design concepts, criteria, the why and the what. As in, this is as part of this video is a combination of design nuggets as well as design patterns. So I'm going to take you through the basis of my reasoning and thought process with regards to the design of the adapter and the adaptee. And so that way, during the video, I'll be discussing that. But the code, I won't go into a whole lot of detail. You'll see the code, you will see it working, but I won't explain all the parts and pieces for that. So first off, let's look at the intent and motivation as per the Gang of Four book, the design patterns book. And as you can see here, the client, let me just change my pointer again. Okay. So the client is just the code that uses the stuff, the adapter in this case. So it's just frequently called the client code or the client. It's not to say anything to do with the client server. It's just the code that uses, in this case, the adapter. Whenever I use the word interface, I hope you know by now that it doesn't mean the I interface kind of thing. It's a public surface of a class. If you look at a class and you look at its public methods and say properties, that is the interface, rather than say API, which is application programming interface. So that API implies it's at the boundary of the entire application. At the class level, I'd like to call that an interface, but I don't mean interfaces. So this is really an abstract base class that has, in our case, two implementations. As per the Golf book, this relationship, you can't see that here, but this is an inheritance relationship, right? So this adapter, these adapters, really the implementations of the adapter interface in terms of the abstract base class. The client is using or depending on that interface or that abstract base class. And then you have any number of implementations, even if one is fine, you don't have to have more than one. When we talk about the reasons for why you would use an adapter or when you would use an adapter, that would probably make sense as to why you would need just one or have just one implementation. Now, each implementation, both of these implementations, are using an adaptee, and I'll go into details of that with more concrete examples, so you're not having to learn the word adapter and adaptee and trying to imagine what they are, because we'll go straight down to the concrete parts that we're going to be discussing in this video. So the adaptee is being used by a composited. Composite is another pattern, by the way, so I didn't mean composited. It's composition. The adaptee, the relationship between the implementation and the adaptee is that of composition and not even an aggregation. If you don't know what is the difference between a composition and aggregation, the subtleties are there. I think I discussed it in my strategy design pattern video. I'll put a link to it over here. So whatever the video is, I'll first find out and then put the link to the video over here. If you don't know what the strategy pattern is, also maybe you might want to take a look at that video as well. And if you're then wondering what's the difference between the strategy pattern and the adapter pattern, be sure to ask me. So this goes for anyone having any confusion about any patterns generally. Maybe once you look at this video also, you're even more confused. Ask me in the comments below. I might just tell you I'll make another video that explains it, because if it's one of those things that I, can't sit and write a whole, book on it in the answer, or it could make for an interesting video. I'll just make another video that kind of compares different patterns The funny thing is, in my mind, actually, I'll come back to this. Let me finish the definition of the pattern and the intent of the pattern as per the golf book, and then we'll come back to this. Okay, so just once you start again. The adapter is being used by the client code. The adapter typically, in my case, is an abstract base class. The implementations are descendants of that abstract base class. This, you can't see the arrows here, but they're showing an inheritance relationship. The adaptee is a thing we are trying to adapt. And that adaptee between the implementation, the relationship between the implementation and the adaptee is that of a composition, not an aggregation. So in this diagram here, I have shown two implementations of the adapter. They're two completely different adaptees that are being composited by each of their respective implementations. The client is really aware of only the base class. So what is the intent as per the golf book? This is directly from the golf book. So I'll just read it out and then I'll try and explain that in my own words. Convert the interface of a class into another interface the client expects. So convert the interface of a class. Here's my class, some class, into an interface that the client, so my client is here, it expects to be talking to something, let's say an A type of interface, but this thing is a B. So the client expects an A, but this thing that you have in your hand is a B, and you're having to adapt from the B to an A, right? So convert the interface of a class, this one, to another interface that this thing expects, the client expects, all right? And then it says the adapters lets classes work together that couldn't otherwise because of an incompatible interface. So it's a very, very simple concept, but it also gets very confusing because then what are the other patterns doing exactly? The other patterns are doing something very similar. They're just not having the same intent. And that's sort of the distinguishing factor. When you look at patterns, you have to understand the intent because it's contextual. This pattern is called an adapter because it is doing that thing. Its intent, like it's simply converting one interface to another. It's not trying to do anything else. The moment that class starts to do something a little more, it could look like a gateway, or it could look like a facade, or it could be looking like some people confuse it with a decorator, and so on and so forth. Right? So the intention is important and the context. So why would I use this class? Where would I use this class? The context is also very important. I'm going to show you the next slide here, which is our actual code we're going to be looking at. So this is one part of the code we're going to be looking at. We have what I have defined and designed a MessageBrokerPublisherBase class. And how do you like the naming convention? I don't know if you're aware of this naming convention I have, which is, most of you probably would have said MessageBrokerBase Publisher. Right? MessageBrokerBase Publisher. I'm saying MessageBrokerPublisherBase because I like the stuff. And you'll see that the next one, the actual concrete implementation. So the concrete implementation of this is MessageBroker RabbitMQ. So instead of MessageBroker Publisher. So MessageBrokerPublisherBase, MessageBroker Publisher RabbitMQ, MessageBroker Publisher Service Bus. Right? That naming implies or allows for the Visual Studio Solution Explorer to order these classes alphabetically, and they'll appear together in your Solution Explorer. If you start to move them around, then they won't appear together, right? Of course, these are long-winded names, so they'll most likely appear anyways together. But you're not saying message publisher or service bus message publisher or something. Then these will not appear in the same place, right? Hopefully that makes sense. And the service bus version, oh, look at that. There's a typo there. I just should probably fix this. So this side is these. And I could just change that also. I could say this is not Service Bus, this is RabbitMQ. And this side is Service Bus. How's that? All right. So the code I'm going to show you, we have a Service Bus implementation. So what I use, Service Bus has a whole library, right? That SDK that you download and use. That's a very intensive library. And in that library, there's one such class called Topic Client. So the MessageBroker Publisher Service Bus implementation will composite the Topic Client that's part of that SDK, and then forward all calls. I'll show you the details, but that's that one implementation. The other one is going to be using the Rabbit SDK, RabbitMQ SDK, to implement the RabbitMQ version of that class. All right. So the idea is that the client would like to be able to use one of both message brokers, but they have very different interfaces. The way you work with those two SDKs is quite different. They come from different libraries, they come from different hierarchies, they got different messages, the data that goes in and out. There's just a lot of stuff. Sometimes that need is a real need in production. Sometimes the need is for testing purposes. So really this talk was motivated by the need to show you how would you test a service bus based application on the local machine when you don't have the ability to have a service bus emulation on the local machine or any other way to test against a service bus based application, because currently the only option is to go to the cloud. And when you go to the cloud, there's just too many issues with that. There's multiple people on a team all hammering away the same service bus. The containers, the paths are all the same, and all hell breaks loose. Plus, you need an internet access perpetually. It's just too much trouble. So I thought I'll show you how to do the same kind of thing where you're testing locally, even though the intention is to use service bus in production. But at the time of testing, at least on your local desktop, you could be using RabbitMQ on the local desktop. So if you've got a whole bunch of people on the team all running their tests, they're running their tests locally, they're not hitting against the same service bus in the cloud. And they don't need the internet access, and you're not paying for that, the number of interactions with service bus. That was the original motivation behind doing this talk, but then I realized that I don't have a video on design on the adapter pattern. So since I was using the adapter to do this, I thought I'll make it hit 2 or 3 birds with one stone. So it's a design nugget video, it's a design patterns video, and it's also how to test with service bus on the local machine video. All right. So now the when and the why would you use an adapter? So the first 2 bullet points here, the only 2 bullet points here are actually, they could be independent reasons, they could be a combination of reasons. As in, you could do this for the one bullet point or the other bullet point, or for both, right? Subclassing, subsetting. Some class has this, tons of methods, really complicated stuff. And you want a simpler version of that. You don't want to be muddled with all the other features that class can do. For example, a charting third-party application or a library, right? It can do all kinds of charts, and even when you pick like a bar graph, there's 20,000 possible permutations of how to use that chart and the stylings and this and that, and it just becomes too much in your application. You're not interested in using that library for all the things you can do. So you want an interface for your application such that it allows you to do the things that you want to control or want to allow. Right? You don't want every dev to be able to do all the possible things using the charting application. So the subsetting of a much larger, more intense, more complicated interface could be for controls, as in you want to define certain things you can and can't do with a third-party library. It could be because you're trying to simplify the interface. It could be, or what other pattern can be used to simplify the interface? Got it? Okay, the facade. And therefore, the facade looks like the adapter. The adapter looks like the facade. It's like, okay, which one am I doing exactly? All right, the next thing is decoupling. And this is, for me, is sort of the number one thing. This is an automatic thing for me. When I'm working with any third-party thing, what is a third party? The .NET library for me can be considered third party. That is when, let's say I'm working with the file system. I consider that for some reason third party. Is, and even though it's part of the .NET, it is coupling me to that operating system. Right now, of course, now with .NET.Core and things are a little different. But let's think of just generally third parties. Either other teams in your organization, or you're actually buying third-party libraries from vendors, third-party vendors. Could be anything that's not yours. I don't ever take a hard dependency on some third-party thing. So let's say we're using Service Bus SDK, right? It's a third-party thing. Well, then let's keep it at a distance. Let's put an abstraction in the front to decouple our application from Service Bus. So tomorrow, if you want to change from Service Bus to something else, then we have that option. Otherwise, we're just completely coupled in with Service Bus. And of course, the subsetting part is then also saying, but I don't care how Service Bus is doing its thing. I want my class. So let's say there's Service Bus, the SDK here. Can you see it? Yeah, SDK here. my application. Me, I'm the application. So I won't be able to talk to this thing, but I'm going to put an abstraction in the front of it so that I can see that the way I want to see it with only the features that I want to use. And if I'm sending it a message, it's my message. It's not its message. They have their own message class in the Service Bus library. I don't want that message class leaking into my application, my main application. So I'm going to put an abstraction in the front and say, I'm going to give you a message. You do what you have to do to talk to that guy. Make sense? What are the classes doing that? The gateway. So yes. So then what's the difference between an adapter and a gateway? Right? Am I confusing you yet? All right. I don't intend to confuse you, but I'm saying that every this is one of those things. So I hope I'm not going to offend anybody watching this video because that's not the intention, but it's something that, I've heard people say, I've felt it myself, and it goes like this. I'm an Indian, but you can't tell the difference. I mean, even Indians can't tell the difference between Indians and Pakistanis and Sri Lankans and maybe some other people, right? And certainly for anybody not from those countries, we all look the same. It's only when you get more familiar with people and you understand their mannerisms, you understand their accents or the differences in their accents and various other things that you start to realize you can actually distinguish one person from another person. You can distinguish one person from a country to another person from another country. It comes with experience, right? It comes with understanding the patterns of people. So you're seeing a bunch of people, they all look the same to you. And the same thing happens with Oriental people, right? Whether you're Chinese or Japanese or Korean, we can't tell. But because I've worked with Koreans and I've worked with Chinese, I can tell another Korean and another Chinese, like by looking at them or by hearing them, speaking, I can tell that's a Korean, natively Korean. Maybe they're all speaking English from a Chinese or from a Chinese. But I couldn't do that before. So it's only after I spent time, the years, with a Korean and with a Chinese in the same team, that I was able to discern the differences, and they look different to me now, right? So it's not like on the first date, like, I didn't even know, and I don't necessarily care whether you're a Chinese or a Korean or an Indian. It makes no difference to me, but I thought they were just both Chinese. That's just like, the normal thing for me. And then I realized, you're Korean? Really? Okay. Then I asked the guy, you're Korean too? No, he said, I'm Chinese. Said, okay, like to me, you're looking the same. I didn't say that, but you get the point. All patterns look the same to you when you're learning them. So till that point, you have to make sure each time you attempt to use a pattern, you go back to that golf book, you watch these videos again, you understand the intent. Should I be using the adapter pattern? Should I be using the gateways? Is this a facade? Like, what is this that I'm trying to build here? So they will look the same. To me, I don't see the reason why anyone sees the similarity. They're totally different patterns for me. But that's because I have spent time with these patterns. I've used them, sometimes incorrectly, as I'm going through my learning process. And years later, seriously, happens years later. You might think today that you know this pattern after you watch this video, but you don't. It takes years to understand when, how, why, and the differences, the subtleties, the differences between, let's say, the facade and the gateway and the adapter. The facade kind of does the same thing. The facade, I don't remember the intent, verbatim, but it simplifies the interface of a complex subsystem. So there's some complexity here. This topic line that I'm talking about is complex. It's got too many features, and I don't want to work with that thing. It's just too complicated. That charting thing that I was talking about, it's got way too many options, and it's just confusing. Simplify the interface of a complex subsystem. A facade makes it easier to use that complex subsystem. Well, that's what we're doing with the adapter too. No? What about the gateway? The gateway is doing the same thing. There's that service out there that's got all kinds of features to it, and it's got its own kind of models that go in and out. And the gateway is trying to say, well, I'm doing the gateway that I'm building. So this is the service out there on the internet, but out here on the internet, and I'm here, and I'm me as in the system. And I'm saying, I don't want to talk to that thing directly because it's got its own data model, and it's just too complicated to talk to that service. Just too many interactions to get one thing done. I'm going to slap on a gateway in the front. I'm going to give the gateway my data. my kind of data. I want the gateway to give me back my kind of data. I'm not interested in working with that service's data directly in my system. So abstract it. And then the gateway handles all of the mappings from my data type to its data types, from its data types back to my data type. Any, let's say, status code error messages come back, convert that to exceptions that I want to see when that occurs and all that. That's the gateway. But then what's the difference between that and an adapter? The adapter is doing the same thing. The facade is in the front of your system. It's like an entry point. That's why it's called a facade. The gateway is talking to, let's say, an HTTP, some TCP-based service. That's why it's called a gateway. The adapter is not in the front, and it's nor is it making, well, in this case, you could say it's making TCP calls to service bus. Right. But it's an infrastructure thing. I'm not using it as a service. Gateways are used for services that provide you with features, functionality, and data back. Messaging is not considered a service in the sense. It's not considered a business application. It's considered an infrastructure service, like a database, right? Our data access layer is not called a gateway. So there is a confusion there, but hopefully that makes sense or the distinction I'm trying to make very lightly here is helping you understand, distinguish the facade from the adapter, from the gateway, and maybe something else. The adapter is very simple, yet people get confused because of, I think, the simplicity or the misunderstanding. So I'm going to show you a few real examples, and then we're going to look at the code. I'm hoping the camera is going to focus on this. So here's an adapter. It adapts from that to that. So this thing is called 3.5 mm TRRS to quarter inch TRRS. So here's my headphone thing. It's a 3.5 mm, but it's a TRRS. And this thing is going to adapt. And now it becomes that. Right? So now which of this is the adapter and who's the adaptee? Can you tell? So this is the adaptee. This is the adapter. This is the adapter. And this is the adaptee. Adapter, adaptee. Right? There's many examples here. What about this guy? Right? You'd use one of these things when you have a need for USB power. You got the USB cable. It would normally go into a computer or a laptop, but you don't have that. And so now you got your wall outlet, and you can plug this in. So this thing adapts the wall outlet to USB. That's an adapter. What about these two? So I've got my phone's USB-C adapter. That's the USB-C. And that's the USB-A. I've got my USB stick. And I can plug this in here. And now as far as my phone is concerned, my USB-A has become a USB-C. It's also an adapter. And on and on. Here's a cable. You won't be able to see it, but this cable doesn't matter. It's not going to work. I use this cable it's got an HDMI, mini HDMI on one end and the normal HDMI on the other end. And my camera's got a mini HDMI, and I use that to get the HDMI feed out from the camera to my Atomos Ninja 5 or V or whatever to record the video on. Oops, I just pulled it out of the camera. Is it being recorded? Yeah, of course, this is a spare. And here is another example of the adapter pattern. Alexa, turn off the video lights. Gone. If it weren't for my monitor, I'd be sitting in total darkness. All right, let's try it again. Alexa, turn on the video lights. Okay. So now, who's the adapter, or what is the adapter, and what is the adaptee? Give you a few moments to think. Okay, let me also think about this. I am the one that decides the interface. I'm saying I want to be able to just talk to something to turn things on and off, right? That's my decision, as in you can't change me in that I'm speaking. So I want to be able to speak. And Alexa is the adapter. Just woke up.
The noun, adapter, can have a few meanings. 1. A person or thing that adapts, makes suitable to requirements or conditions. 2. A connector for joining parts or devices having different sizes, designs, etc., enabling them to be fitted or to work together. 3. A device that connects an electrical plug to an outlet that has a different plug shape. 4. A device with a cord that plugs into an electrical outlet and functions as an external power supply for a small or portable electronic device, usually converting AC current to DC.
Why didn't I think of that before? Okay, now I've got all these lights around the room, including what I call the key light, or what is known as the key light, the main light that illuminates your subject, and a bunch of lights in the back that kind of illuminate certain parts and kind of make the background interesting. So I can turn off just the key light. I can turn off any one of the lights at the back. There's, I think, about 7 or 8 lights that come on and off. Or I can turn them all on and off together. So let's say I decide to turn off this key light. Alexa, turn off the key light. That's it. So just the key light is gone. The other lights in the background are still on, and they haven't been impacted. Alexa, turn on the key light. Right, there you go. So I'm the client. She, I'll take her name again, you can go through the whole rant again. She's the adapter. And on the lights end, there's again the whole picture, if you will, the topic client or the RabbitMQ client that we'd be using now to do that adaptation, or the adaptee. So the adaptee is the combination of the thing that can work with Alexa on one end, but also turn on and off lights on the other end. Right? So that's the adaptee. But the combination is the adapter, if you remember. The composite of adapter and adaptee is the adapter, the implementation. Right? So my voice gets translated to physical things being turned on and off, and therefore she is the adapter. But the combination of her and all the lights put together becomes the adapter, right? And it could be one light at a time, different adapters being orchestrated simultaneously to turn all of them on and all of them off. Right? Too much detail. If you would like to see the stuff to do with IoT and stuff, then let me know in the comments. I have a few videos, 3-4 videos on my channel on IoT, but if you're interested in seeing more of that stuff, if you're interested in programming that stuff or building the hardware, I do both. I design my own circuits and PCBs. And so I built about 5 or 6 PCBs for which I have been intending to make videos on YouTube, on this channel, but I've been just too lazy. It's just a lot of work. All the PCBs and everything is done. Just haven't gotten around to shooting. I'll probably need, 2 cameras, one overhead to get the PCB, and then the C# code and the C++ code and stuff. So anyway, if you're interested, let me know. Anyway, let's get on with the adapter pattern. Anyway, so there's many kinds of adapters. We're all already familiar with it, which is why this pattern is interesting. All right, let's look at something else. So I'm going to show you now in diagram form. So here is what the client wants. This is the client saying, I want something that looks like this. Each of these protrusions and intrusions. Intrusions? What's the opposite of protrusion? Insets? I don't know. It's not intrusion, of course, but whatever. I'll call it insets, right? So the protrusions and insets, let's say that each of them is signifying a certain method with a certain signature and certain inputs and certain outputs, right? So each one is saying, I want, this is the name of the method like this, and it's got this input, and it's got that output. Here's another method that's got another thing. It's got certain inputs and certain outputs and so on. These two are not looking like the same. So imagine this to be our application that says, hey, I want a message broker like that. But we don't have a message broker like that. We got something that looks like this. Let's say this is the RabbitMQ SDK thing or the Service Bus SDK thing. And how do we sort of bridge this gap? No, I didn't mean the bridge pattern. That's another pattern. What am I doing? This is the adapter. I meant bridge the gap in terms of the English language, not the design pattern. There are some people who say that the adapter is only the adapter pattern when the interface cannot be modified. It is something that it's fixed. Let's say you're working with a system and that system has a certain API for, let's say, a message broker that it can't be changed. You can't change that. That system has existed from before, and it requires something that looks like this interface, the orange one. So there's an unchanging thing on one side, and there's an unchanging thing on the other side, let's say RabbitMQ or Service Bus. So these two things cannot be changed. You don't have the option to change this code or that code. That's when you want to use an adapter. And that's fair in the sense that is a valid scenario under which you would use an adapter. But is that the only scenario? I don't think so. So what I'm doing, or what we're doing in this video, is we are saying this orange thing, the interface that we would like, is something we are defining. Why? Because we want to decouple ourselves from, whether it's a RabbitMQ or a Service Bus or an MessageMQ or a ActiveMQ, whatever that may be. We don't care. We don't want to know. Our need is very simple. We want to be able to publish a message. We want to be able to subscribe to a message. The message, the thing that we send, the message type, that's ours. It's not RabbitMQ's, nor is it Service Buses, or nor is it MessageMQ, whatever. It is ours. And when we get a message, it's our message back. We want to build that abstraction, that decoupling between these providers, RabbitMQ and Service Bus, and our application, so that in the future, we are not tied to an implementation specific thing. Plus, if we need to test something, we might have the option to do that as well. And maybe in production, and I've done this in some cases, not for message brokers, but actually even in message brokers, we started off going down one path, and then at some point in the middle of that project, we had to change from RabbitMQ to Service Bus. I mean, that would have been a nightmare if you use that SDK all over the place. In fact, if you look at the configuration provider, that's one of the .NET things that I abstract. If you haven't seen that video or you don't understand what I'm talking about, it's really, really interesting, and it's also really, really important. You should take a look at that video. I'll put a link to that here. That's the roles and responsibilities of a configuration provider. Super important. I think if people think I know that. No, I'm not talking about that. I'm talking about the roles and responsibilities. Why would you do that? It's super, super important. Please take a look at that. Anyway, that's another pattern. Well, I don't know the name of the pattern. It's a pattern, meaning I've been using it for years. So it's a pattern, but I don't know the name for it. All right. So anyway, so the idea was that if I had not initially itself decoupled myself from RabbitMQ, as in I let the RabbitMQ stuff leak into our application, it would have been a bigger nightmare to modify that. Whereas when we went from RabbitMQ to Service Bus, we just made another implementation for that same interface, the adapter interface. And we had Service Bus implementation, and we got the opportunity to test locally with Rabbit while testing. When the test ran on the build server, it ran against Service Bus. So we had the benefit of both worlds, right? If I had not done the decoupling or the abstraction before, it would have been quite a bit more painful. We would have ended up with the adapter pattern at the end of the day. Anyways, I was just saying I'm doing this ahead of time. I have no idea what the future holds for me. I don't like to be coupled to third-party things, and for many other reasons, I always put that adapter in the middle. I normally call it an abstraction. In fact, the adapter pattern also is called a wrapper. I just don't like the word wrapper. It's a wrapper, utility. These become terms that you use everywhere. And now you can't tell the difference between this wrapper and that wrapper. So yes, conceptually it wraps. This is the RabbitMQ thing. And our adapter wraps composites. Changes this API to whatever, on the outside of my hand, that API. right? But it's a wrapper. And so you can call it, in fact, in the golf book, they do mention that aka adapter, wrapper. But don't use that term because it's just too simplistic in its meaning. It can mean many things, so it's too generalized. All right, so here we have the interface that we would like in our application. This is what we have. How do we get this thing to be usable by this? How do we get this thing to be able to use that? And so in order to do that, what we need is an adapter. Okay, of all the three things, which one is the adapter? Take a look at it again. Did you get it? Okay, here it is. The combination of these two is the adapter, meaning that's the adapter, that's the adaptee. But basically, you're saying, as far as this application is concerned, it sees this surface, this API, and this is a perfect match for the application. So as far as the application is concerned, the composition of these two is the adapter, right? But if you look at our original pattern here, or the UML, that's the adapter. The combination of these two is nothing but an adapter, right? So we have our implementation here. This is the box in the middle, and that's let's say the RabbitMQ. It's not just the RabbitMQ channel also, by the way. It's a whole host of classes that RabbitMQ requires you to use in order to get to work with RabbitMQ just to publish a message. And of course, we have another version of it for the subscribing part. So anyway, so because this adapter is just an interface, base class, its implementation is the one that composites the adaptee. Going back to the other slide here. This guy here, this combination, even though I'm drawing it as two different things, this green box is sort of internal to this orange thing. So the combination here is the adapter. So this is what it looks like in use, but basically you can have this being the adapter, and that's the client code that's using the adapter. And of course, I'm only showing you one. Imagine another orange box here whose left-hand side looks like this, which is the mirror image of that. But the right-hand side doesn't look like this. It looks like the Service Bus version, or whichever other version that you have. By the way, how do you like those shapes? I had to draw those shapes. First time I attempted doing this kind of weird thing in PowerPoint, but it worked, I think. So let me know if you like the shapes and the whole jigsaw puzzly kind of thing going on there. All right. So now that draws us to the end of the presentations. Let's go look at the code. I'm going to just explain the code, the reasoning behind that, and of course, then show you the whole thing working. All right. Okay. First, we have the MessageBrokerPublisherBase. And this is the base class. So the base class's interface is that. That's it. Got a method called publish. That's it. It's got a method called dispose. That's all. That is how I would like to see. So the reasoning behind this interface, if you will, was I'm trying to do two things. One, I certainly want to decouple myself from my system, from the service buses of the world, the RabbitMQs of the world, or the MSMQs of the world. I have a simple need: publish a message. I don't care how you do it. Right? I want you to publish my message. I don't want to have to deal with your message and have that coming into my system. So that abstraction or the decoupling is important, but the subsetting also is important. If you look at the topic client or the RabbitMQ channel and connection and all that, they are way too expensive, complicated, not expensive, complicated. Too many methods, too many options. Like, oh my gosh, I'm just trying to do the simple thing. I want to just publish a message. So I want to simplify the interface, but that's a facade. No. I'm talking about the adapter. Don't mean to confuse you, but I'm having a bit of fun. All right. So my reasoning for this is this message is mine. This is not Service Bus's message, nor is it RabbitMQ's message. This message is defined right here, and it's got a bunch of properties. Now, during this process of determining what the message should be, first of all, you're saying, what do I want as a business? What do we need? What all data do we intend to post to our message brokers? What of that information what the message brokers themselves already have, such as a message ID or a session ID or whatever correlation ID. Look at that, and there's a commonality between what you need and what the brokers already provide, right? So of course, then that's a cool thing. That's that least common denominator kind of thing I was trying to get across the last time. The commonality. So if you identify the commonality, say, okay, cool. Then I need a correlation ID. They both have a correlation ID. Perfect. I need a message ID. They both have a message ID. I don't know. I forget now. But that's a very hard process. That's where you spend your time designing the classes, not the implementation part, but certainly on the design side. What should that message look like? Once you determine the message, and you have to examine, at least if you have, in this case, RabbitMQ and Service Bus at your disposal, as you know, you intend to use both of them. If there's three things you want to intend to use, then you look at all three of them and find the commonality across all three. The more, the merrier, but the more, the harder it gets, the design of it. And then it comes to the implementations. Okay, so let's say they didn't have correlation ID. Maybe one did and one didn't. You need a correlation ID in your system. You have to think, okay, so does the other thing that doesn't have a correlation ID, does it support something like custom properties or whatever else? Can I have my own properties? I can have something called a correlation ID. So even though it doesn't natively support it, it doesn't have a feature that allows me to do that. You follow? So there's a bunch of reasonings and thought process. This is pretty hard. Even for a little thing like this message broker and the subscriber, it's actually pretty tough to get it just right. So I suggest spending your time comparing the two, and don't buy into, never be mad at your designs. Never be mad at your design. I can go through, like a week of design and just totally trash it and start again. Never be mad at your design. Be ready to change. Maybe somebody gives you some advice, they say, oh, Bashir, you could have done that. Oh, God, I didn't think about that. And then you're stuck. Should you throw away your week's effort? Should you throw away your baby and give in to this other person who just came out of blue in 2 seconds, told you something was better? Yes, if you think it's better, just do it. Right? Just throw it all away and do it again. But it's hard, this process. So I have these various properties here. The byte array, which is the body, the message ID, and these are all strings, and so on. And at this point, I don't know, because I missed. See, as usual, I missed the datetime of the message and stuff like that. So that's probably, but datetime, of course, is easy to add on. I'm not trying to justify my bad design here, but I missed it. In the real world, I wouldn't have missed it, because I'm making this as a exercise here. It's glaringly obvious to me now that it's not there. All right. So that's my message. This is my message. This is nothing to do with RabbitMQ. You can look at the namespaces. There's nothing here about RabbitMQ or Service Bus. And that's the other giveaway or, kind of thing you should be looking at. Now, in this case, I've got my implementations for both the Service Bus and the RabbitMQ versions here. So you're seeing both the namespaces over here. But in reality, you would not. You would just see, this is also the Service Bus thing. I've aliased it. In reality, you just see these two namespaces for the publisher base. Okay, so now that we understand the publisher base, remember there's a publish core abstract method and a dispose with the bool argument abstract method. So let's look at the RabbitMQ implementation now. Right, so this is MessageBroker Publisher RabbitMQ. Let's look at that implementation. It gets a little complicated, but we've defined a constructor that takes the connection string and the topic exchange. If you don't know the RabbitMQ Service Bus thing, please take a look at those videos here, the introduction to message brokers and each of the RabbitMQ and the Service Bus videos. I'll put a link to all of them up here. Take a look at those. Without that, this one may not make sense. All right, so I won't go into the details of what RabbitMQ requires. This is all RabbitMQ specific stuff. I'll call out some of the highlights. The method signature here is important, as in this took a while to determine what it should be for the two different descendants we have. In C# family or C family languages, that constructor signature is not important because they don't inherit constructors. In other languages they do. So, but nonetheless, if one of the implementations requires a certain constructor argument or set of arguments, try and see if the other one can do the same, right? So there are some nuances here that I had to kind of battle with regards to constructors and even the method signatures, because they each have the need for that information at different times. By different times, I mean, for example, here. In this case, in order to create the connection, I don't actually need the topic. You see how it's going? The topic exchange is not being used to create the connection. But I think, if I remember correctly, the Service Bus version requires the topic exchange and the queue in order to create the connection. So that's the disconnect here. But nonetheless, this is what it is for the RabbitMQ thing. At the time of publishing, I get one of my messages here. And what it does is it maps between my message things and RabbitMQ message things. There's no such thing as a message in RabbitMQ. There's properties and then there's the body. The message has a body. That's our body, but it has properties. So I'm mapping between the properties of the message to their properties. And then on the channel, I call basic publish. Right? So that's how I publish, even though for me on the outside, I just say, here's my message, please publish it. I really don't have to get into the details of all this stuff for RabbitMQ. In the disposing area, I just need to dispose of everything that needs to be disposed. In this case, our connection needs to be disposed. I dispose of that in the RabbitMQ version. In the Service Bus version, I have the topic client. You see here, in order to create a topic client, I need the connection string and the topic exchange. Right, so this topic client, forced my hand with the signature. And the Rabbit signature had to be, of course, then matched the same because my abstract base class has now the signature. Well, actually, it doesn't. And the RabbitMQ version had to conform, which wasn't required, but I didn't want it to be confusing. When to create the Rabbit broker, version of the broker, you need these two arguments. And then to create the Service Bus thing, you need these other arguments or something. I want to keep it as similar as possible, even though in C# or C family languages, that is not required. Those constructors don't have to be the same for different descendants. Okay, and then the publishing is different again, but similar idea. I get my message here, and I basically map from my message to Service Bus message. They also call that thing message. So I have to just alias it to SP message in this class, so the class file here. And then once I've correlated the whole thing, I do a send async. In RabbitMQ, the send is not asynchronous, whereas over here it's asynchronous. So this signature returns a task. And this is the other thing that the Service Bus implementation forced my hand on. The method had to return a task. And so the base class, if you look here, says it returns a task. The RabbitMQ version just returns a completed task. This is not doing this. This basic publishes, there's no asynchronous version available in the Rabbit libraries. So I just fake the task return here. Whereas the Service Bus version is actually asynchronous. So you have to await it here. So the await is not part of the method signatures. As a result, you can have different implementations where one is actually asynchronous, the other one is just returning a task. Again, you dispose all the things that need to be disposed. That's the implementation for the publisher. Right, now we'll look at the implementation and the design and the ideas behind that for the subscriber. It's a little more complicated. Okay, so that's the MessageBroker subscriber base, our interface or the adapter interface. And that's all there is to it, barring the 3 abstract methods. So we have a subscribe method that takes a callback. So if you remember from the message queues thing, they both had an eventing mechanism. So we are saying this is the callback. When I say subscribe, I'm really saying when to the library, the RabbitMQ, the topic client, when you receive a message, call me back on this delegate with my message. They have to convert their message into my message and so on. Right? So it's doing that part. So that's what the subscribe is doing. That's all that is there's a message received event args type that comes in, which I've defined. So all of this is something I've defined. So this event args type, this is here's the message as part of the event that I receive. I get the message itself. I get the acknowledged token. So I can complete the message or act the message. So it gives me that token that I can use to say, please act this message or complete this message. And the cancellation token in case I'm using that. So the subscribe method says I want something that I can call back to. And then that calls the core. And the acknowledge just takes the token and then calls the core. And so that's the adapter interface. All right, so let's look at the implementation. Now we got the RabbitMQ version of the implementation that descends from our base class. And the constructor here requires a connection string, requires a topic exchange, requires a queue name. So remember, this is the subscribers. So subscribers don't know topics. They just know queues in Rabbit, right? So you can see here, the topic exchange is not even being used here. I'm asking for it in the constructor only because, again, Service Bus forced my hand. In order to create a topic, what do they call it in Service Bus? I needed all three of these. The topic, the exchange, because apparently you can't receive messages from a queue or a subscription in Service Bus unless you know the exchange. It seems a little weird to me. But anyway, that's their signature. So my hand was forced here again. I didn't, in this case, because this is a constructor, I didn't have to conform, right? But as I was using it on the consuming side, the client side, client code, I felt a bit, like I'm just going to change the signature for the RabbitMQ version also to conform to the version that the signature that the Service Bus constructor has, so it looks the same. It's easy to use and treat, similar. So here I even put a comment here saying that the topic exchange parameter is not required by the RabbitMQ channel. So even though I have it coming in here, I'm not actually using it. And then I'm going through the process of setting up whatever Rabbit requires me to do for its types and everything. I set that up. I have private members set up over here. So when somebody actually calls subscribe, they're saying, please call me back on this callback. So then what I have to do on my RabbitMQ implementation side, I have to subscribe to that message myself. And so I'm internally subscribing to that message, to this event here, this much of it. And then when I receive the event from Rabbit, I map the Rabbit data to my message. So I create an instance of my message. And then I call back that callback with that event message received event args. The message received event args is a composition of its own thing plus the message, right? So it's got the delivery tag separately, it's got the cancellation token separately, but it's also got the message that I mapped from the RabbitMQ message, this ea.body and ea.basic properties and so on, to the message. And then I call the callback with the event args. Now this event args is something I defined. It's not a RabbitMQ thing, it's not a Service Bus thing. So that way my client code can be receiving messages from a broker without knowing where it's coming from, and it's in its own terms, right? The API is something that the client says, I want you to give me back my message, I'm not going to deal with your message. Right? Similarly, I want to give you my message for you to send, to publish, and you do what you have to do to get my message sent. I don't want to know how you have to do it. That's again the decoupling or the abstraction part of the adapter pattern. All right, so that's that. And then when we have to call back the ACK or I call it acknowledge. We ask for the token, and then in this case, we'll use RabbitMQ's thing to do the acknowledgement here. So the composition aspect of the adapter is important because you're really just forwarding on the calls. And it's not simple. Like even you can see how the receiving the message is fairly complicated. It's not always simple. It's not like a simple mapping of sorts or forwarding of sorts. So I'm calling it forwarding. You forward the call onto the adaptee that you are containing as an adapter. You're compositing the adaptee and you're forwarding calls onto that. But it's not obviously as simple as that. It's just forwarding on calls. Some cases it is, but some cases it's not. Especially when you're dealing with all these events and asynchronous stuff, it gets fairly complicated. All right, so now let's look at the Service Bus implementation. So here we have the Service Bus class of the implementer, and it's got its constructor, same signature as the RabbitMQ version. But you can see here, in order to create a subscription client, I need all three of these things. So I need the connection string, of course. I need the topic exchange and the queue name. Not sure why the subscription client needs the topic exchange. I shouldn't have to know the topic exchange when I'm a subscriber. That doesn't even make sense to me. Right? RabbitMQ is very clean. You just need to know the queue. You don't need to know the topic or the exchange, but you need to know the queue. So I think in that sense that the API there is a little cleaner. In Service Bus, apparently I need to know that this topic and that queue, which somehow, to some extent, defeats the decoupling capability of topics and exchanges. Okay, nonetheless, that's Service Bus. Now for the subscribe, again, I receive the callback, but internally, I got to work with the Service Bus's own stuff to be able to get to the point where I can subscribe to a Service Bus event, and then that's all stuff going on over here. This code actually is very similar to the code from the previous video on Service Bus and RabbitMQ. And then I have busy constructing a message received event args and my own message by using the SB message information and plus other things. I guess the lock token or the acknowledge token that I call it here. I call it acknowledge token. The Service Bus thing calls it lock token. And I call the callback here, passing it that message received event args. So basically this all the stuff I have to do here in order to subscribe and parse or map the Service Bus message to my message and so on. That's done here. Right? And then because this, yeah, that's it. All right. And then in Service Bus, we also have this exception thing. You really don't see that here, but there's an exception handler as well. So you have to specify that as part of Service Bus things. I've specified that here. And this is going to just throw that exception here. I've not done the same kind of thing. Rabbit doesn't have a separate message exception handler delegate. All right. And for the acknowledge, I get the acknowledge token, and then I call the client's complete async, right? And then I do the dispose. So far we've seen very briefly the two adapters and their adaptees, which are none other than RabbitMQ and Service Bus, right? For which we got the two adapters. So that base class is the adapter base class that I showed you, the MessageBrokerPublisherBase and MessageBrokerSubscriberBase. And the two implementations are the also adapters that composite the adaptees, which are the RabbitMQ things and the Service Bus things. Okay, now let's see this whole thing in action. So on my local machine, I've got RabbitMQ set up with certain exchange and queues, same names. I have to use the same names in Service Bus and in RabbitMQ. So that becomes a requirement, but that's not unusual. I mean, your code is your code, and you want your code to work with RabbitMQ and Service Bus, so the queue names would be the same, or the topic names or exchange names would be the same. So that's not unusual, but I have to do that on my local machine, make sure that my Service Bus topics and subscriptions match my RabbitMQ on the local machines, exchanges and queues. All right. That's already been done. And when I got a Docker, I don't think I ran the image, did I? Let me make sure I did that. Yeah, see, it wasn't running. Oops, none of that. This is going to run my image. This is the same image I had from my previous videos. All right. So, and on my Service Bus sides, they're both sort of synced up. I'm going to run the application. I'll use some of the code here, the two connection strings that I have, one for the RabbitMQ and the Service Bus thing. I've got these two constants, and I can flip the entire behavior either by using the RabbitMQ thing or the Service Bus thing. And then the topic exchange names and the queue names. Right? So it's all common stuff except for these two. The top two here and the bottom two here, things are common across both RabbitMQ and Service Bus. All right. So in my application, I got a method that says create broker clients, giving it the RabbitMQ constant or the Service Bus constant. That's it. Right? And then if you look at the implementation here, basically got a switch case statement. If you want the RabbitMQ version, it creates an instance for the MessageBroker Publisher RabbitMQ and the MessageBroker Subscriber RabbitMQ. If you ask for the Service Bus version, you get the instance for MessageBroker Publisher Service Bus and MessageBroker Subscriber Service Bus. So it's returning, if you know, this is a new signature for C# 8 or 7, I think, 7, where you can return multiple things from a message. So I'm returning an instance of the broker and the instance of the subscriber if you send me this MessageBroker type string. Right? Very simple thing. What would you call this, by the way? This method, what would you call it? If you said factory method, you'd be wrong. There's a factory and there's a factory method pattern. Of course, both of them have a method in them. This is what I would call a factory. It is a method in this class, but if I were to define it as a separate class, that class would be a factory, and this would be the method in the class, but you won't call this method the factory method. But it could probably be the factory pattern, right? But not the factory method pattern. All right, so this is abstracting the construction, given the identifier for what it is you want. It constructs either the publisher subscriber for RabbitMQ or the publisher subscriber for Service Bus. That sort of simplified the code over here. So by calling that, you immediately got a message broker and a message subscriber. So now once you got the publisher, I mean message broker, the publisher and the subscriber. So once you have the publisher, publish a message. So you knew up one of your own messages, you set up all the values in that message. And then you set up the subscriber also, saying, hey, I want to subscribe, in the subscriber. And that's the message received event args MRI. And it's really, I'm really getting at my message from there. So, and from my message, I'm extracting the different properties and the data and the body, which is a byte array, convert that. So all of this is my code. This code has no notion of RabbitMQ or Service Bus or whatever else in the future. Right? It's completely agnostic of. It's decoupled from all of that. Now, I've of course implemented the factory in the same code here. So this factory here, which now suddenly again also knows about the implementations. This is a method, but that's the reason to define this in a factory. When you use a factory class, in this case for the message brokers, and the method this is, create broker, publisher, create subscriber, that class is coupled to the adapters for Service Bus and RabbitMQ. But your main application is not coupled to those classes. It only knows the base class, abstract base class, the message broker publisher base and message broker subscriber base. So if you do want to use something like this, make sure you use a factory class that you are pulling out the dependencies or the known dependencies into the factory, and let your client code just be aware of the base class. It doesn't know the descendants. Right? This should have no coupling between the descendants and the actual abstraction, if you will, the interface. But that's what we have. So now we're going to see this running. Currently set up for RabbitMQ, so running locally. Right? So let's cross our fingers and see. You just see some output on the console application here. The data that is set up. So we sent a message, but then this is what we received back. So we did accomplish the publish and the receive with RabbitMQ. What I know is RabbitMQ. Let's look at the publisher and indirectly call this stuff here. Let's put a breakpoint here on the basic publish, right? And similarly on the RabbitMQ subscriber piece, we'll do the here when we receive the message in RabbitMQ itself, right? First, we should hit the publish breakpoint, which is here. And once we do that, we should receive the message from the received message or the subscribe message, but again, the RabbitMQ versions of it, all right? Okay, and then we can close that. Remove these two breakpoints. And now let's put them in the Service Bus versions. This is now the Service Bus class implementation. I'll put in the publish, I'll put one at the bottom here, just before publish. And in the subscriber, again, that's the Service Bus subscriber. And the subscribe here, I'll put one on the, received callback here. Okay. And now in the main code here, I'm just going to swap out this RabbitMQ constant to the Service Bus constant. That's all I'm doing to change the behavior and the fact that it's using either the Service Bus version or the RabbitMQ version. So I'm not shown all of the testing part of things. The idea is to show you that, with a simple config setting, you can swap out the entire behavior of the system. And by behavior, I mean, is it using RabbitMQ or Service Bus? Right? So if you do need to use this for testing purposes, of course, you might have to take your own measure to make things cleaner if that is required, but the features are there. So I'm going to now make this source bus, that's source bus. And now when I run this application, you'll see the breakpoint sitting on the source bus side. So here we are in our source bus class. Is it the publish message? And now actually publishes, and then we subscribe. So we now receive the message from source bus, come here, with the subscribe, and there's the same message. So the output is exactly the same. It's not like the output is going to be different because I've not made any difference. But I'm just going to run it without the breakpoints. So publish and subscribe. There you are. Same output, same behavior, but using local RabbitMQ or using source bus. So I hope this video was interesting. I hope you've learned a few things. If you have, please give me a thumbs up, and I will see you next time.